There we go. Okay, here is the question, everybody. And this is really, really exciting for me.
Oh, he knows.
The question is,
Okay.
what is the relative volume scale of the Earth to its moon? Now, what you guys see right now in front of you, what you see right now in front of you is an actual to scale model of the Earth and the moon. So it is a picture of the Earth and a picture of the moon, and they are relative size to scale. So I want you to look at those, and then I'm going to actually hit participants and see if I can put everybody's hand down, and I can do that myself. You guys don't have to worry about that. Lower all hands. Okay. Now, I want you guys to now raise your hand if you have an idea of what the scale is. Is it 1 to 2, 1 to 3, 1 to 4, ... Don't really know. Who's got some ideas about the relative scale? And you remember, guys, that last week we learned that the relative scale from Earth to Pluto was 1,000 to 1. Pretty amazing stuff. So I'm going to go first with Brandon. Go for it, buddy.
4.
So what do you think it is?
4.
So you think it's 4 to 1. Okay, I like that. That's a good start. Gabby, what do you think it is? Gabby, you'll have to unmute yourself.
0 to 100.
You think it's 100 to 1. 100 to 1. Courtney, what about you? Oh, not Courtney. Oh gosh. I think that's your mom's name. Charlotte. Charlotte. Yeah, Charlotte. Yeah, please change your name to Charlotte, because it's really hard when I see the parent's name come up. But in any event, tell me what you think it is. What is that relationship?
4 to 2.
4 to 2, which is similar to 2 to 1. Very nice. William?
It is 4 to 1.
Everybody seems to be anchored on that 4 to 1. Very interesting. Allie, what do you think?
3.5.
3.5. Oh my gosh. Well, I have to tell you something. I'm a little excited about 3.5, and I'll tell you why. Because in terms of diameter, 1 diameter, 2 diameters, 3 diameters, and about 1/2, Allie is right. However, I did not ask you for the diameter ratio or relationship. I asked you for volume. So I want everybody right now to do this for me. I'm going to stop share, and I am going to share with you a camera that has my, let's see if I can move this over. So this camera has Play-Doh in it. And I want everybody to take their Play-Doh. If you don't have Play-Doh, don't worry. You can do this with a piece of paper. And I want you to create either a cylinder, which looks like this. This is a cylinder. It's got a circular base and a circular base. And when you turn it sideways, it looks like a rectangle. So if you guys create a cylinder, and I'm going to roll out my cylinder. And let's see if we can get the participant group back. There we go. And Gabby, did you have another question, love?
Combine all the Play-Doh together.
Yeah, well, you should take one piece of Play-Doh. I actually do not care how big your Play-Doh piece is. Okay? Now, if everybody,
Else?
say again, sweetie?
Should I still have something for something else? Should I still lose some more Play-Doh?
No, you do not need it for anything else. Take your only piece of Play-Doh. Now, I want you guys, remember what we did last week. We were able to take our measurement tool, which is, and mine is by centimeters, 1, 2, 3, 4 centimeters. Each centimeter has 10 millimeters. Can you guys please measure your centimeters? And by the way, I really like mine today. Do you know why? Because mine is 11 centimeters. And that means, who can tell me what is 10 times 11? All you have to do is tack a 0 on to the end of number 11. So here's my 11. And if I multiply it by 10 to get millimeters, all I have to do is take 11 and put a 0 at the end. That's 110 millimeters. Now that's Mr. Kramer's. And I am going to mark off every 11 millimeters. Every 11. So 11, 22, 33, 44, 55, 66, 77, 88, 99, and 110. Now, it doesn't matter if it's not perfectly accurate, but do you guys have now kind of tenths? Count them to make sure that they work. Ready, go. 1/10. Help me out. 2/10. 3/10. 4/10. 5/10. 6/10. 7/10. 8/10. 9/10. And finally 10/10. And I always love to write fractions. I love to write fractions because 10/10 gives me exactly how many holes. How many holes is 10/10? You can say it out loud if you've got it.
1 hole.
Wow, that was awesome. That was awesome. So now I want you guys to cut off 1/10. I want you to cut off and try to cut straight down.
That's too big of a cylinder here. Wait.
And I just cut off 1/10. So now I am left with 1/10. And I am also left with 9/10. Now, do not mash up either of them. Take your 9/10 and put it aside. Take your 9/10 and put it aside, please. Now,
Put this piece aside.
I want you guys to make another cylinder out of the 1/10. And I want this cylinder, I want you to try to make it exactly 10 centimeters if you can. Right now, guys, mine is only 9 centimeters. So I'm gonna smush it a little more to spread it out evenly to make 10 centimeters. Oh boy, guess what, guys? my cylinder is now exactly 10 centimeters. Now, how many of you are where we need you to be at the point where you've got 10 centimeters? And I'm actually going to write this out. I'm going to write out 10 centimeters. And I want you guys to make a little incision every 2 centimeters. So therefore, you're going to go 2 centimeters, 2 centimeters, 2, and 2. Or let's count by twos. 2, come on guys, 4, 6, 8, and 10 centimeters. Does everybody have it now broken up into 5 equal pieces? And Allie, you have a question?
Mine's 11 and a half.
Well, then smush it in a little bit, honey. Look at me, Allie. Allie, smush it in a little bit so it becomes a little bit less. You can work with 11 and a half, but it's really great to work with 10. Now what I want you guys to do is this. I want you to take your plastic knife, remember Brandon, plastic knife, and I want you to cut off 1/5. So right now, what you have done is you have cut off 1/5 of 1/10. Please take the 4/5 and put it aside. You should now be looking at something called 1/5
Why'd you cut it
of
into 5 pieces?
1/10. Who can tell me how to multiply 1 by 1? If I take 1 times 1, which is called the numerators of this fraction, who can tell me what 1 times 1 is? Don't say it out loud. On 3, 1, 2, 3, go.
1.
And it is 1. And you guys know what I'm going to ask you now. What is 5 times 10? The denominators of the fraction. On 3, 1, 2, 3, go.
50.
Guess what, guys? You have just given me a piece which is 1/50th of the whole. And I want you to make a sphere out of it. Make a sphere out of it. And now I want you to place it down right where it says 1/50th. And I want you to take all the rest.
I'm not doing it anymore.
And I want you to smush the rest of it into a sphere.
Smush that you do rest. Make that into a sphere.
Now, guys, guess what the big sphere is?
The Earth.
The big sphere is the planet Earth,
Do you have any
and
green?
the little sphere is the moon.
This
So
doesn't
you got the moon, which is 1/50th, and you got the Earth, which is 49/50ths.
No, I mean.
So I want everybody please to hold up to the camera their Earth and their moon. And what I'm going to actually do is I'm going to change the screen share now, and I'm going to change it to that picture that we started with. And I want you guys to tell me, does it make sense? Does it make sense? Look at the picture that I'm showing you right now. Does it look like what we're looking at right here? The moon and the Earth. And guess what, guys? When you guys said your answers, you were kind of pretty far off because the moon is way smaller. It is a 50-to-1 relationship. Technically, it's 49, but let's go with 50. So the Earth to the moon is 50 times. Even though the diameter, as Ali pointed out, was actually 3.5 times, that is the linear distance. But the volume which you're holding, that is 50-to-1. Now, everybody, let's look at a really cool picture. The next picture I'm showing you is a picture of the Earth, which is 8,000 miles across. That's called the diameter of the Earth. Now, you remember that we just figured out that the Earth is a 50-to-1 volume to the moon. Now, do you know that because Earth is 1,000 times bigger than Pluto, how many times is the moon bigger than Pluto? You would have to actually take the number 1,000 and you would have to divide it into 50 equal pieces. Now, who thinks they know what is 1,000 split up into 50 equal pieces? That's 1,000 divided by 50. I'll write that out a little differently. 1,000 divided by 50. Does anybody have any ideas? Because division is really, really fun. It's the opposite of multiplication. And multiplication is just repeating addition. And who thinks they have an idea for me?
E. With the times 10.
Okay, Charlotte, go for it.
I think it is 100.
Well, that's a really, really good guess. If I take 1,000 and I divide it by 100, I'm sorry, by 10, then I get 100. And that's because 100 times 10, Charlotte, equals 1,000. But if I divide 1,000 by 50, it's something smaller than 100. Ara?
50?
Well, if you had 1,000
What's 10
and divided it by 20, you would definitely get 50. But we are dividing by 50. William?
I think it was 1,100.
Well, that is interesting because it's got to be smaller than that because you're dividing 1,000 into 50 equal pieces. Raymond, what do you have for me, Raymond?
Get 500.
What am I dividing?
Go ahead, Raymond.
20.
That
And that is correct, everybody. The moon is 20 times larger than the smallest planet in our solar system. Pretty amazing stuff. Now, do you guys think that Earth and the moon are this close together?
No.
Guess what? They are nowhere near this close together. In fact, you would need 30 Earth diameters. And I'm going to show you, I made a really fun picture. You ready for this? You would need, everybody count with me, guys. You would need 1, 2, 3, all the way to 30 Earth diameters. Now let's count by 8,000. 1,000. Are you ready? We're not going to say the number 1,000. We're just going to count by 8. You guys ready? Here we go. 8, 16, 24, 32, 40, 48, 56, 64, 72, 80. Now stop there for a second. And if you were at 80, what would you add now? 88, 96. So let's keep going. 88, 96. Oh, come on, guys. 104, 112, 120, 128, 136,
To the earth.
144, 152, 160, 168, 176, 184, 192, 200. Come on, guys. 208, 216, 224, 232, and 240,000 miles. So when you look up at the moon, I want you to say, Mom and Dad, the moon is 240,000 miles from Earth. It would be 30 Earth diameters. So you would need 30 Earth diameters in order to get to 240,000 miles. Now, I want you guys to take your moon and your Earth and spread your hands as far apart as you can. And guess what? You're gonna have to double that, because the Earth is more than double that distance away from the moon at this size. It is so far. So far. You would have, and here's what I did, guys. I measured my Earth, and I figured out that my Earth is about 8 centimeters across. Now, therefore, I did 8 centimeters times 30. And guess what? I got 240 centimeters. Now, in order to do 240 centimeters, guess what I needed? I found a meter stick, and then I had to double it, because each meter stick is how many centimeters? Raise your hand if you know. Raise your hand if you know how many centimeters is in 1 meter. And Ara, I'm going to ask you, go for it.
30.
2 meter 6.
So,
30.
But this is in inches, so you can't. But this is about how far it is.
So, Ara, I am waiting for your information. And Brandon, while we're waiting for Ara, why don't you tell us what you think? 1 meter equals how many centimeters? Go for it, Brandon.
No, don't use that, because that was inches.
Brandon, you're going to have to speak if you did raise your hand, buddy.
40.
Well, it's not 40. 1 meter is not 40 centimeters. Allie, what do you have?
100.
And that is right. Everybody write it down. 1 meter equals 100 centimeters. So if I have 240 centimeters, I am going to need to have 1 meter plus 1 meter plus another 40 centimeters. And together, that's going to give me the distance from my Earth to my moon. Yours might be a little different. So you guys can play with that later. You can make your own models of the Earth and the moon. Now, there's something I wanted to show you, and let me see if I can find this, because I think you'll really find it interesting.
Where are you going?
So what I did for you guys is this. This is the planet Earth on the lower left side. That's the planet Earth. And do you guys see the little green dot that's right next to the planet?
Yeah.
Do you guys see that?
Yes.
That green dot represents 254 miles, which, by the way, is a little more than the distance from Boston to New York. And guess what that is? That's how high the International Space Station is in our orbit. Now, guys, doesn't that seem ridiculously close to Earth? Well, guess what? Look at the other green dot in the middle of the 16,000.
What green dot?
That green dot right here is 12,000 miles, and that is the altitude of a GPS satellite. Now, you guys are not going to believe this, but the moon is so much farther. The moon is so much farther away than the space stations or anything else we can comprehend. And I'm really, really excited that you guys got to see what it felt like to be from the Earth to the moon. Now I want to ask you another question. And the question is, I'm going to show you now a picture of,
What's in the mystery box?
I'm going to show you a picture of the sun and the moon. Now, guys, the sun is 1,300,000 times bigger than planet Earth. The Earth is 50 times bigger than the moon. Now, can anybody help me figure out how many times the sun is bigger than the moon? And in order to help me, you guys could help me multiply 13 by 5. Now, don't say it out loud, but you know that multiplication is repeated addition. So we're going to add 13 plus 13 plus 13 plus 13 and plus 13. Now, another way to think about this is it's really 10 plus 3 plus 10 plus 3 plus 10 plus 3 plus 10 plus 3 and plus 10 plus 3 more. Now, who can tell me what is 5 tens? Go ahead, guys, on 3. 1, 2, 3, go.
50.
And who can tell me what is 5 threes? 3, 6, 9, 12, one more.
15.
And who can tell me what is 50 plus 15?
65. 65.
So guess what, guys? On page 5 of your packet, you can put in 65 and then look at how many zeros. How many zeros? Let's count them. 1, 2, 3, 4, 5, 6 zeros. Let's tack them on. Now, do not read that number to me yet. Do not read that number to me yet. Are you guys ready? On 3, focus on the 65. 1, 2, 3, go. 65 what?
65 million.
And the answer is 65 million. Guys, the sun is 65 million times bigger than the moon. Then I ask you this question. And Joshua,
5 million
Maxwell, Cam,
times bigger than the moon.
Sabrina, Ryan, I want you thinking about this. Why is the sun and the moon, why do they appear to be the same size? We know that the sun is 65 million times bigger. Who has an idea? Victoria? Go ahead, Victoria. And Victoria, I can't hear you, so I'm going to move on to Ryan. Go for it, Ryan.
The reason that they appear the same size is the sun is farther from us than the moon.
The sun is farther than us from the moon. But the question is, and that's a beautiful thing, Ryan, you're in 100% right, but we have to know how much further. And Gabby, what do you think? I'm trying to unmute you, Gabby. Keep yourself unmuted, love. Go for it.
I don't know. I was thinking, I thought they were the same exact distance away. That's why I thought.
And that would be, look, if the sun and the moon were the same size, Gabby,
I mean,
then
the
yes,
same
they would be the same. They would be the same distance away, and that would make a lot of sense. Ara?
I was going to say 65 million miles away is the sun.
Wait, say that one more time.
65 million miles away.
Well, that's actually interesting. It is even further away than that. And Guy and Brandon, what do you think?
I think 500 million.
Interesting. That's a little bit too far. You guys are going to love this. Are you ready?
Yeah.
Are you ready? Now, we know that the sun's diameter is 400 times larger than the moon's diameter. The sun's diameter across. So guys, watch this. I could put 400 moons across the diameter of the sun. 400.
400.
And guess what? The sun is 400 times farther from Earth than the moon. So guys, look at my picture. This is Earth. By the way, this is you. This is you right on planet Earth. The next time you look at the moon, you know that you're looking at it right up to your face. Whereas the sun, which is 400 times wider, is also 400 times further away. And guess what, guys? That's why when there is a solar eclipse, a lunar eclipse. Is that right? Let's see. A solar eclipse. When there is a solar eclipse, the moon goes in front of the sun, and because it appears to be the same size, it completes completely blocks the sun from our view. Now you wouldn't believe it, guys, but the last time there was a solar eclipse, we could not see it in the United States. It was only visible in places like Africa and Australia, and I think parts of Europe. And I have some more bad news. The bad news is the next solar eclipse is coming in 11 days. And you're like, Mr. Kramer, why is that bad news? It's bad news because we probably won't see it. Now, some of you might be lucky enough to travel to Africa. They will be able to see it across the entire continent of Africa, parts of Southern Europe, and across much of Asia. So if you and your family are planning to do any of those trips, and by the way, don't go there just to see the solar eclipse. Why? Because the clouds could be out that day and you'll miss it anyway. But if you're there, and on June 21st, maybe we'll see some of it. Maybe we'll see some of it in the United States. So I hope you guys look at the mathematics of the moon and the sun and try to understand their relationship. Now, the next thing we are going to do is this. I want you guys to go to page 10, please. Go to page 10 in your document. And I want everybody right now to pick up their pencil. Everybody go to page 10. And do you guys think this picture
Way down there, you.
is pretty much what the picture of the solar system looks like? And what I want you to do is I want you to look on the left side, and that represents the sun, and the P on the right side represents Pluto. Now, if you want, you can even take your little pencil and write Sun and Pluto. And what I want you to do, only using the first letters of the planets, for Mercury, just put an M. So I would put an M right here. Now, you don't have to put them where I put mine, but I want to put where I think the planets are relative to each other. So I'm going to put Venus next. I'm going to put Earth, Mars, Jupiter, Saturn, Uranus, Neptune. And guys, this is what I think. This is what I think. This is what I think are the distances. Now, this is what I want you to do with your family the next time you have an opportunity. Now, I'm going to go back and I'm going to share with you again my iPhone camera. And I want you guys to go to the very last page of your packet. So go to the very last page of your packet. And I want you to rip off the piece of paper that looks like graph paper on both sides. Just rip it off. And what I want you guys to do is by the way, somebody's talking to a parent, and I'm going to just mute them real fast. So I want you guys
Oh, it's already set.
to fold this the long way. I call this hot dog. This would be hamburger.
Do it so I think you can see.
This is hot dog. So I want you guys to make a nice fold. And make a really good fold and put it down on your paper. Now, here's what we're gonna do. I'm gonna write down the words, what I think. This is what I think the planets are in relationship to each other. I'm going to start by putting an S on the left side. Why don't you guys do that? Put an S on the left side and then go all the way to the right side and put a P for Pluto.
You do this. I'll do the
So
calculator.
S and then P. Now remember, in between, there's Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And what I want you to do is put down again what you think they are. So let's do this. I'm going to put mine, I'm going to put my Mercury, and then my Venus, and then my Earth, and then my Mars, my Jupiter, my Saturn, my Uranus, and my Neptune. And does anybody see a funny word that the planet acronym makes, Camilla?
Sun.
I kind of think that that's a little scary. I kind of think that that's a little scary. Kind of a neat thing to see. Now, does anybody's look any different than Mr. Kramer's? Or do they all look pretty much the same? Well, guess what?
I think.
Oh, nice job, Doris. Everybody turn the page over now and do the same thing with an S and a P. And what I want you to put there is what really is. So you want to put what really is. And I'm going to tell you how the planets are apportioned in the sky. Are you ready? First of all, I have to give you some really important information. When we measure distance with Mr. Kramer's centimeter ruler, we do it by centimeters. When we measure things by meters, we use the meter stick. But when we measure distances of planets, we use what's called, are you ready for this? You don't have to write this down. Astronomical units. And guess what? And they're called AUs, AU for astronomical unit. 1 astronomical unit equals the distance from planet Earth to the sun. Now, Ara, you gave us 65 million miles. Would you guys believe that the sun is 93 million miles away? The sun is 93 million miles from Earth. In fact, do you know that one of my students asked me, Mr. Kramer, how far is the sun from Earth in sun diameters? So take the diameter of the sun It's 120, guys. It's 120. So are you guys ready? Here we go. I want you to write next to Pluto 40 AUs. Because Pluto is 40 times further from the sun than Earth. 40 times further. Now, here's what I want you to do next. I want you to find the middle point. Find the middle point between the sun and Pluto and make a dot. And I think that the halfway point is around here, but guess what? You know how you can test it? Fold your paper in half and see where your crease is. And look at that. I was pretty close. My crease is pretty close. Now, you're not going to believe what planet is right there. That is the planet Uranus. So everybody put a U next to that middle dot. And now, if Pluto, listen really well, if Pluto is 40 AUs from the sun, how far is Uranus from the sun in AUs? Please raise your hand if you know what half of 40 is. And you're gonna all say it on 3, so unmute yourself. Come on, you guys can do this. On 3, 1, 2, 3, go.
20. 50.
Everybody say it. 20 is exactly half of 40. And so Uranus is exactly 20 times further from the sun than the Earth. And it's halfway to Pluto. Now, I want you guys to do the same thing. And I want you to find the middle point between Uranus and Pluto and make a dot. And if you want to see if you're correct, you can always fold your paper to the halfway mark, but I think you guys can find a halfway point really well. Now, who can tell me what planet that is? Who can tell me what planet is halfway between Uranus and Pluto? Now, who can tell me? Come on, raise those hands. Who can tell me what is halfway? Tess?
Neptune.
That's it. Everybody write down N for Neptune and write down the number of AUs. Don't say it out loud, but you know that it's halfway between 40 and 20. It's halfway between 40 and 20. And I'm going to let you write it down. Pick up that pencil and write it down. Come on, halfway between 20 and 40, it's 10 away from each. On 3, 1, 2, 3, go.
30.
40.
30. 30.
And guess what, guys? Neptune is 30 times further from the sun than the Earth. Now the fun begins. I want you guys to make a dot at the halfway point between the sun and Uranus. Between the sun and Uranus. Now, this one is harder than the Neptune question. Who can answer the question what planet this is? Joshua, do you know? Victoria, Sabrina, Doris, Camilla, Alice, Maxwell? What do you think? Go ahead, Gabby.
Which
And Gabby, keep yourself unmuted, honey, so that way when I call on you, you can answer right away.
My brothers are really noisy.
A little bit louder, love.
My brothers are really noisy.
Oh, I appreciate that then. Thank you very much. Tess, what do you have for me? What do you have there, Tess?
I accidentally raised my hand.
Okay, you guys ready? I want you to put a big S there for Saturn, and you could even put a little ring around it. That is Saturn, and who knows what the halfway point between 0 and 20 is? Who knows the halfway point between 0 and it is 10? So write down 10 AUs. Now, by the way, if 1 AU is 93 million miles, by the way, somebody's speaking, and please be quiet now, thank you. If 1 AU is 93 million miles, then 10 AUs is 930 million AUs. It's almost 100 million, right? 930, it's almost a billion AUs away. Okay, or miles away. Okay, here we go, guys. Make the halfway point from Saturn to the sun. And guys, that's your Jupiter. And Jupiter is 5 AUs. About a half a billion miles away. And now it gets really, really tricky. Are you ready for the tricky? Make a dot at the halfway point and make a little arrow and write AB. AB stands for the asteroid belt. So the asteroid belt is 2.5 times further from the sun than the Earth. And go halfway. Now that is now the planet Mars. And the planet Mars is a little more than 1 AU away from the sun. It's actually 1.25 AUs from the sun. And now go halfway from the sun to Mars. And that, everybody, is Venus.
Oh, I got my flip-flop hand.
And now go halfway from Venus to the end of the paper, and that's Mercury. And guess what? You're gonna have to locate Earth now, which is between Venus and Mars, and the big E for Earth is 1 AU away. Now, how many of you, open your piece of paper now, how many of you guessed correctly where the planets are located from the sun? How many of you did? Guess what? Oh, Doris did? That's awesome, Doris. I never did. And Joshua did? Awesome. When I look at the picture of the solar system, I always see it looking like this. even if the relative sizes are correct, and I'm going to show you now a different screen. I'm now going to show you a different screen. Guys, this is the picture we always see. And now you know that the solar system looks nothing like this at all. In fact, this is what it looks like. Pluto is 40 AUs, Neptune is 30, Uranus is 20, and then halfway Saturn, halfway Jupiter, halfway asteroid belt, halfway Mars, halfway Venus, and halfway Mercury. And then Earth is just between Venus and Mars. So how many of you were so surprised, like Mr. Kramer, that I couldn't even believe that that's where the planets are? And I want you guys to have some fun. So what I put in your packet is I put graph paper, 2 pieces, and I also put a description of this activity so you can go through it with your parents and your grandparents. Does everybody want to go travel to the moon and to Mars like Mr. Kramer?
Yes.
Let's do it.
Wow.
Everybody, I want to see your, uh-oh, guess what? My moon just got smushed. Show me your Earth and your moon. And we're actually going to count from AUs. Are you ready? -40 AUs. -30 AUs. Neptune. -20 AUs. Uranus. -10 AUs. Saturn. -5 AUs. Jupiter. -2.5 AUs. Asteroid belt. -1.25 AUs. Mars. -0.6 AUs. That's Venus. -0.3 AUs. That's Mercury. And Earth is what? 1 AU. Let's do it, guys. 2, 4, 6, 8. Buddha, we appreciate Matthew. Matthew. Go, Matthew. To the moon, everyone. I'll see you next week.
Good afternoon.
Good afternoon, Mr. Moon.
I mean,